So, okay. Friends, so far we have discussed about the random variables and different gate problems basing on random variables. So now let us see the different distributions on random variables. The first distribution and the basic distribution is binomial distribution. Let us see the definition. Okay. So if x is said to be a binomial random variable, when can a random variable is said to be a binomial random variable? When it allows the values from 0 to n, if it has values from 0 to n with parameters n comma p and probability mass function is, see friends, in binomial distribution the probability mass function will be p of x is equal to ncx into p of p power x into q power n minus x. You might have seen this formula in your intermediate second year, right? Okay, fine. When 0 to n, it should be x value should be there. Remember the formula, friends, ncx into p power x into q power n minus x, and 0 otherwise. Okay, friends. Next, here there is a relation between p and q, friends. That is nothing but p plus q equals to 1 always. Here q is nothing but 1 minus p. Here p represents number of success rates, q represents number of failure rates. Okay, friends, in this way we will define a binomial distribution. Let us see the different conditions and the formulas for mean and variance in binomial distribution. Okay, see friends, in binomial distribution there are three conditions. See, observations are independent of each other. Okay, friends. Next one, probability of success is always constant and mean value is always greater than variance value. This is very important. Mean value is always greater than variance value. Here mean value formula is n into p. N is number of observations and p is the probability of success, and variance number of observations into probability of success into probability of failure, so npq. So this is the way we will be using these two formulas in different problems, friends. Now let us see how to do the problems in binomial distribution. So let us do a problem basing on binomial theorem, binomial probability. See friends, here find the probability of getting a sum 9 exactly in any 2 in 3 times. Okay, fine. What he is asking, when a pair of dice is rolled, I should get sum 9. 3 times I am rolling, but 2 times, exactly 2 times I should get the sum. So in the sense, see friends, here n equal to 3 and x is equal to 2. Yes or no? What is the probability of success? P is equal to, we should get sum 9, right? So sum 9 in the sense, what are the chances of getting sum 9 in a pair of die, friends? This is 3 comma 6, 6 comma 3 and 4 comma 5 and 5 comma 4. Yes or no? There are 4 chances. Therefore, probability of success in out of 36 is, that is nothing but, P equal to 4 by 36. That is nothing but 1 by 9. If P is 1 by 9, what is Q value, friends? 1 minus 1 by 9, right? So it is 8 by 9. Yes or no? So now let us apply the binomial distribution formula. That is nothing but ncx into p power x into q power n minus x. So what is n, friends? 3 times we are rolling. Out of 3 times we have to get 2. Next, what is p? 1 by 9 and x is 2 into q power n minus x. Q in the sense 8 by 9. 8 by 9 into n minus x, that is nothing but 3 minus 2. So 3c2 in the sense 3 into 2 by 2 into 1, that is nothing but 3, and 1 by 81 into 8 by 9 whole power 1. Okay, so 3 into 1 by 81 into 8 by 9, that is nothing but 3 3s are 9, and so 8 by 243. This is the answer. So this is 8 by 243 is the probability of getting a sum 9 exactly in any 2 in 3 times with a pair of dice. Okay. So next question, friends. The probability of number of defectives in a lot, in a lot is 35%. There are 6 items. Okay. In a lot means in a box. There are 6 items. Okay. The probability that the number of defects in a loss is 35%. So 35% chance are there to get a defective one. So find the probability that at most 1 are defective. At most 1 in the sense, what he is asking, P of at most in the sense less than or equal to or greater than or equal to. It is compulsory less than or equal to. Right, friends? At most means less than or equal to. Random variable x is less than or equal to 1. This is what he is asking. Less than or equal to 1 in the sense P of x less than 1 plus P of x is equal to 1. Yes or no? What is P of x less than 1? X less than 1 is nothing but x equal to 0, right? Less than 1 is 0. There is nothing there which is negative. Okay, fine. Now P of x equal to 0. Here, what is the value of n, friends? There are 6 items. N equal to x, 6. And what is the value of probability of defectives in a lot is 0.35. 35% in the sense, and P is nothing but 35%. That is nothing but 0.35. What is q then? 1 minus 0.35, that is nothing but 0.65. So this is the value of x, this is the value of x individually. So now NCX, NCR, applying the binomial theorem, what is the formula? NCX p power x q power n minus x. Yes or no? So what is the value of n here? 6. 6c0 into p means 0.0. That means let us suppose p power x in the sense 0, right? Just let us apply these values later. Next q, what is the value of q? Q power n 6 minus 0. Yes or not? Yeah, this is the one plus what is p of x equal to 1 friends? 6c1 into p power 1 q power 6 minus 1. Yes or no? Yeah. Now what is 6c naught? 1. P power 0? 1. So q power 6. Right? Q power 6, right? Now yeah, q power 6 plus what is 6c1 value friends? 6c1 is nothing but 6 into p into q power 5. Yes or not? So now how can I write this? Can I take q power 5 common? Into q plus 6p. Yes or no? So what is the value of q friends? 0.65. 0.65 whole power 5 into 0.65 plus 6 into what is the value of p? 0.35. Yes or no? So what is the value now? 0.65 whole power 5 into 6 into 0.35. 0.35 into 6. 6 5 is 30. 6 3 is 18. 18 plus 3 is 21. This value is 2.1. 2.1, right? This value is 2.1. So 0.65 plus 2.1. So 0.65 in whole to the power of 5 into what is the value friends? 2.75, right? Yes. So this is the answer. In virtual calculator, if you want to calculate or else leave like this. Options in this options because this is whole power 5, right? So no need of, he won't give you the maximum number. Simply he will give like this in the option. Okay. So this is the value 2.75 into 0.65 whole to the power of 5. This is the way how you need to approach when he gives like this. At most or at least you need to perform binomial distribution in this way. Okay friends. So next one. So next one friends, Poisson distribution. Okay, here probability of a random variable will be e power minus lambda into lambda power x divided by x factorial when lambda is greater than 0 and x is less than infinite from 0 to infinite. Next, otherwise it is 0 friends. Remember this formula. And here in Poisson distribution, why we use this Poisson distribution in the sense in order to measure a defective item or to measure an arrival rate or also death rates. So in a week how many death rates are happened. So in that case if any question is framed, so we can use Poisson distribution friends. And also arrival rate. So how much late he is coming and how much cars have been arrived to the stop, how much buses are arrived to the stop. In this case, basing on the time, we can use this Poisson distribution, and time dependent problems can be solved by using Poisson distribution friends. And very rare occurrences. Okay, so what is the probability of getting a storm in this particular month in the any season? In that cases, in rare occurrences also we will use Poisson distribution. Okay, now let us see the conditions of Poisson distribution. So the conditions for Poisson distribution is observations are infinitely large. In the sense n value should be very much higher when compared to p value. Either probability of success is very small. Okay friends, so n value should be, number of items should be very large friends, and the number of success rate should be very small. In that cases we use Poisson distribution, and n into p is equal to lambda. N into p value will be equal to lambda, where p equal to lambda by n. In order to, I already told that e power minus lambda into lambda power x by x factorial, right? So what is lambda is nothing but the product of number of items into success rate. Next, the values, mean value is nothing but expectation value is nothing but lambda, and also variance is also equal to lambda friends. Okay, so here mean equal to variance friends. Okay now, so this is very important conditions and formulas. Let us do some problems basing on Poisson distribution. Okay friends, let us see an important question on basing on Poisson distribution. Okay fine, on an average 8 customers are arriving from 8 am to 10 am. See, 8 am to 10 am there are on an average he is saying, that means he is telling the mean value. Okay, in Poisson distribution what is the mean friends? Lambda only, right? That means average 8 customers are arriving from 8 am to 10 am. That means 8 am to 10 am in the sense 2 hours. 2 hours in the sense 120 minutes. For 120 minutes 8 persons are arriving. Yes or no? On an average, 8 are coming. Find the probability that for a period of 30 minutes. For a period of 30 minutes we want. So 120 minutes, 8 customers in the sense. For 1 minute, how many customers, friends? 8 by 120, right? So for 30 minutes, how many customers? 8 by 120 into 30, right? So 3 4s 12, 4 2s 8. That is nothing but for 30 minutes, 2 will be the mean value. Minimum mean value on an average, 2 customers will be arrived based on 30 for a period of 30 minutes, right? So the lambda value will be 2 here. Okay, fine. So find the probability for a period of 30 minutes, that is for the average of 2, no customer is arrived. What is the no customer is arrived means? What do you mean by no customer is arrived? That means P of x equal to 0, right? No customer means 0 customers. No customer is arrived. What is P of x equal to 0 formula in Poisson distribution? Generally, the Poisson distribution formula is e power minus lambda into lambda power x by x factorial for P of x equal to small x, right? Now, in this formula, lambda is 2, x is 0. Yes or no? Now, let us apply. So, e power minus 2 into 2 power 0 by 0 factorial. So e power minus 2 in 2 power 0 is 1, 0 factorial is also 1, that is nothing but e power minus 2 or 1 by e square, anything. Next, so no customer arrived in the case, the probability is e power minus 2. Next, second one, what he is asking, exactly 2 customers are arrived. Exactly 2 customers are arrived in the sense P of x equal to 2. That is nothing but e power minus 2 into lambda value is 2, 2 power x value is 2. So 2 divided by x factorial, 2 factorial, right? So this is nothing but 4 by, this 2 square is 4, 4 into e power minus 2 divided by 2, 2 2 is 4, right? So 2 into e power minus 2. Fine, this is the exactly 2 customers arrived. Now, at least 1 customer is arrived. What do you mean by at least? At least is nothing but greater than or equal to 1. 1 he is asking, so greater than or equal to 1. So, the solution here is P of, this is the third one, x is greater than or equal to 1. What do you mean by x is greater than or equal to 1, friends? This is nothing but 1 minus P of x equal to 0, right? I told you that at least 1 in the sense 1 minus P of none. Did you remember in probability formulas? P of at least 1 is 1 minus P of none. So 1 minus P of none of them arrived. None of them arrived is nothing but e power minus 2. So the value will be 1 minus e power minus 2. Right? So this is the one. And next one is the fourth one. At most 1 customer is arrived. At most in the sense less than or equal to. So P of x less than or equal to 1. X less than or equal to 1 in the sense. So P of x equal to 0 or P of x equals to 1. What is P of x equal to 0? Already we got e power minus 2. That is nothing but e power minus 2 plus P of x equal to 1. We have to calculate. Here x value is 1, lambda value is 2. So e power minus 2 into 2 power 1 by 1 factorial. That is nothing but e power minus 2 in, plus e power 2 into e power minus 2. Yes, so the final value will be 3 into e power minus 2. So this is the value of at most 1 customer arrived. This is 3 into e power minus 2 and at least 1 customer arrived is 1 in minus e power minus 2 and exactly 2 customers arrived is 2 into e power minus 2 and no customer arrived is e power minus 2. So this is the way. So only the thing is by give at what particular period he is asking. If for that we need to find lambda. Okay friends, basing on the given data. Fine. So this is the way to approach for given Poisson distribution formulas. So next question friends, the probability of defective item is 5 into 10 power minus 4. The probability of defective item, okay, there are 6,000 items are there and find the probability that exactly 5 defects and at most 2 defects. Listen carefully, here what he is asking, what he has given n equal to 6,000 items. We have 6,000 items and the probability of getting a defective item is p equal to 5 into 10 to the power of minus 4. See, n is a large quantity. Here 10 to the power of minus 4 in the sense 0.0005. That means which is very small when compared to this. That means now we can apply Poisson distribution by looking at the given data. So now what will be the value of lambda? If it is a Poisson distribution, we need to find lambda first. So what is the formula of lambda? N into p, right? So 6,000 into 5 divided by 10,000, right? So 3 zeros gets cancelled. 5 2s are 10. 2 3s are 6, so the lambda value is equal to 3. Now what he is asking exactly 5 defects. Exactly 5 defects in the sense P of x equals to 5. Yes or no? P of x equal to 5, right? So P of x equal to 5 in the sense, what is the formula, friends? E power minus lambda into lambda power x divided by x factorial, right? So x value is 5 and lambda value is 3. So e power minus 3 into 3 power 5 whole divided by next 5 factorial. Yes or no? So just leave like this. Okay friends, now another thing, second question. This is exactly 5 defects. Is e power minus 3 into 3 power 5 by 5 factorial. Now what he is asking, at most 2 defects. At most in the sense, greater than or equal to or less than or equal to? Less than or equal to. So P of 2 defects, right? So x less than or equal to 2. Yes or no? How can we get P of x less than or equal to 2? Less than or equal to 2 means 2, 1, 0. So P of x equal to 0 or P of x equals to 1 or P of x equals to 2. Yes or no? So these three, yes, P of x equal to 2. That's all. So what is P of x equal to 0, friends? Here x value is 0, lambda value is 3. So e power minus 3 into 3 power 0 divided by 0 factorial plus e power minus 3 into 3 power 1 by 1 factorial plus e power minus 3 into 3 power 2. This is 2, friends. Okay, yeah, x is equal to 2, right? By 2 factorial. Yeah, now e power minus 3 power 0 is 1 and 0 factorial is also 1. So e power minus 3 into 3 power 1. 3 power 1 in the sense 3 into e power minus 3 plus this is 9 by 2 into e power minus 3. This is nothing but 9 by 2 is nothing but 4.5. Right or not? So 4.5 into 3 power minus 3. So 1 plus 3 is 4. 4 plus 4.5 is 8.5 into e power minus 3. So this is the value. Fine. So at most 2 defects is nothing but just keep less than or equal to 2 and expand this like this and apply the Poisson distribution formula. You will get 8.5 into e power minus 3. So this is the way we need to approach. But look at the question carefully. He has given n items is 6000 and the possibility of success is very much low. These two are very much small, this is very much small, tending to 0 and it is going to, it's very large. Infinity is in the sense going to very large. So by looking at this data carefully, we need to understand that the question itself is framed basing on Poisson distribution. So remember the formula and apply to each other, whether it is exactly at most or at least be careful regarding that. Okay, fine. Now, next question. So, okay friends, now let us see another important thing. Let us see uniform or rectangular distribution. So far we have seen binomial distribution and Poisson distribution. Now another thing is uniform distribution, which is also called as rectangular distribution. So see the definition. A random variable x is said to have a continuous uniform distribution over an interval a comma b. There is an interval a comma b, so it should be continuous all over the interval if its probability density function, that is PDF, is constant over the entire range. Whatever might be the range it is, the probability density function should be constant, friends, right? So in that case we can say that it is a uniform distribution. For example, if I can draw the graph, see friends, suppose this is f of x and this is x. Here there are values a and b. For this a and b values, it should be constant, friends. This is constant, right? The value is not changing here and the value is nothing but 1 by b minus a. So this is what uniform distribution or rectangular distribution. Why it is rectangular? This shape is in the form of rectangle, right? That's why they are telling that rectangular distribution or uniform distribution. Uniform in the sense the value is not changing in the entire range. This value is constant to 1 by b minus a. So f of x is 1 by b minus a is less than x less than b and 0 otherwise. 0 in the sense the remaining part is 0. So in that way he is telling us. Fine. So always remember k value is nothing but 1 by b minus a. This is value is nothing but k. Got it? This is what rectangular distribution or uniform distribution is. Now let us see the mean and variance formulas on uniform distribution. So now friends, let us see the 3 formulas for uniform distribution. First one, the mean formula, that is mu, is b plus a by 2, which is also called expectation. So expectation in the uniform distribution is nothing but a plus b by 2 or b plus a by 2. Next, expectation of x square, this is called mean square value. Did you remember? Mean square value. Expectation of x square he is asking. It is expectation of x is b plus a by 2. Expectation of x square value is b square plus ab plus a square by 3. Expectation of x square in the sense this is a continuous distribution. So a to b x square f of x dx. Right? Next one. Variance. Variance is sigma x square equals to b minus a whole square by 12. Then friends, what is standard deviation? Standard deviation is nothing but square or root over variance, right? So how can I write b minus a by root 12? That is nothing but b minus a by 2 root 3. 4 3s are 12, right? 4 is nothing but when it is under root, 2 comes out. So b minus a by 2 root 3. So these are the formulas of. So what are the formulas for uniform distribution? Remember. So friends, let us do this problem. This problem is GATE 2008 question. This problem is GATE 2008. Okay, this is a very easy question, friends. See, x is a uniformly distributed random variable that takes values between 0 and 1. Okay friends, x is a uniformly distributed, that means uniform distribution that takes 0 and 1. That means, in the sense, what is the uniform distribution formula, friends? F of x equal to 1 by b minus a for a less than or x less than b. Right? Yes or no? 0 otherwise. So what are the values of a and b he has given? That means f of x equals to 1 by 1 minus 0 for 0 less than or equal to x less than or equal to 1. Yes or no? What is the value of f of x? Is now 1. What he is asking, the value of expectation of x cube. In the sense, expectation of x cube is equal to integral 0 to 1. So what is the expectation of x formula? Whatever is there comes here into f of x dx. Yes or no? So now what is f of x, friends? That is 1. So 0 to 1 x cube dx. So what is the value? X power 4 by 4 from 0 to 1, that is nothing but 1 by 4 minus 0 by 4 is nothing but 1 by 4. So which option? I think it's option C, right? So this is the way to find the solution. Next one. So next question, friends. A random variable is uniformly distributed. Yes, uniform distribution is there over the interval 2 to 10, that is nothing but 2 to 10. Okay, this is A, this is B. Okay, its variance will be, what is the variance formula for uniform distribution, friends? So b minus a whole square by 12. Am I right or not? Variance of x in uniform distribution. Now this is 10 minus 2 whole square by 12, that is nothing but 8 square by 12, which is 8 8s are 64 divided by 12, and this now this value cancels. 4 1s are 4, 6 4s are 24, 4 3s are 12, that is nothing but 16 by 3. I think which option? Option A. Got it? This is GATE 2008 question. Please note it. Now next distribution. Okay friends, now so far we have discussed binomial, Poisson, uniform or rectangular. Now we are going to see exponential distribution. See, a continuous random variable, it's not discrete, it's continuous, friends. Continuous random variable x, assuming non-negative values, is said to have an exponential distribution with parameter theta if theta is greater than 0. That means in exponential distribution, theta is the parameter. In Poisson distribution, lambda is the parameter. Okay, next, if it's a probability density function is given by, so this is the probability density function in the exponential distribution, that is f of x equal to theta into e power minus theta x, exponential in the sense this one. Here this is the parameter, theta into e power minus theta x for x greater than or equal to 0, and 0 for x for 0 is otherwise. Right friends, when x is negative, the function is 0. When function is non-negative, when x is non-negative, f of x is e theta into e power minus theta x. Now for exponential distribution, the mean value, that is expectation, is 1 by theta. Variance is v of x, nothing but 1 by theta square. Okay, so basing on this exponential distribution, now let us solve few problems. Now before seeing the questions, friends, look at the conditions for the exponential distribution. First condition is it measures the service rate. So generally we will go to hotels, some people provide some service to us, right? How much service they are providing for us? What is the probability of getting the food that we are when we went to host a hotel? So in that cases, it measures the service rate, friends. We will use the exponential distribution. And reliability component, how much quality it is, the component is. We can use reliability exponential distribution, and we can also calculate lifetime of any component by using exponential distribution and inter-arrival rate. So inter-arrival rate is nothing, is also you can be calculated using service rate, inter-arrival rate, lifetime, reliability of your components. These type of problems can be used, can be calculated by using exponential distribution. We have already seen the mean or expected value of random variable in exponential distribution is 1 by theta. Variance is 1 by theta square. Now, can I write 1 by theta square as 1 by theta by theta? Yes. What is 1 by theta again? Expectation. That is nothing but variance equal to expectation divided by theta. Okay, when theta is one value, it becomes 1, when variance will be expectation of x, both will be equal, friends. Okay, when variance is less than expectation of x, theta is greater than 1. That means when theta greater than 1, variance will be less than expectation of x. When theta is lies in between 0 and 1, variance will be greater than expectation of x. So these are the conditions. Now let us see the questions. Okay, see friends, assume that the duration in minutes of a telephone conversation follows the exponential distribution. He has mentioned exponential distribution. F of x equals to 1 by 5 e power minus x by 5, x greater than or equal to 0. The probability that the conversation will exceed 5 minutes. Here, this is very important. Will exceed 5 minutes. What he is asking, probability should exceed 5 minutes. Right? Exceed 5 minutes is x greater than 5, right? So, he should call more than 5 minutes. Up to anytime, at any time he can talk, up to infinite time period he can talk, but he should talk more than 5 minutes. In the sense, what does it mean exactly? P is 5 less than x less than infinite, right? That's all, no? This is nothing but this equation, more than 5 up to infinity, right or not? So this is the probability that we need. That is nothing but, what are the limits, friends? 5 and infinity. So integral 5 to infinity, always a continuous exponential distribution is a continuous random variable. Okay, now fine. So f of x dx. Yes or no? What is f of x, friends? He has given 1 by 5. So integral 5 to infinity. So he has given 1 by 5 e power minus x by 5 dx. So 1 by 5 comes out, and integral e power minus x by 5 dx. So this is 5 to infinity. So 1 by 5. So this is nothing but e power minus x by 5 divided by 5. Divided by 1 by 5. Right, e power minus 1 by 5 into x, right? So 1 by 5 comes down, this 5 will get cancelled. So limits are 5 to infinite. So if limits are 5 to infinite, so what is the value, friends? So e power minus x by 5, upper limit by lower limit is 5, upper limit is infinity. So e power minus infinity by 5 minus e power minus 5 by 5. This is nothing but 0, and this is nothing but, how can we say, friends? E power minus infinity is 0, and this is nothing but minus e power minus 1. That is nothing but 1 by 1 minus 1 by e. So there is no option, I think. How can we say this? I think it is, maybe we went wrong. 1 by 5 integral e power minus x by 5 dx, and this is x minus 5, right? Yes. So 1 by 5 integral 5 to infinity e power minus x by 5 dx. 1 by 5 integral, okay, fine. Yeah, this is minus here. Okay, this is minus here, minus 1 by 5, right? Yeah, minus 1 by 5. So minus will be there in front. Okay, so 5 will get cancelled, minus 1 will be there, that minus is here. So what we will get now? See carefully. So minus e power minus infinity by 5 minus of minus e power minus 5 by 5. So this is 0, e power minus infinity is 0. Now minus into minus plus e power minus 1, that is nothing but 1 by e. Yes, which option? Option A, friends. Okay, see, if we miss minus, the option is not there. So careful, be careful. So here e power minus x by 5, in the sense minus 1 by 5 will be in the denominator. Okay, so in this way we will proceed the exponential distribution. Now look at the next question. So next question, friends. The time required, he is asking in hours, time required to repair a machine in exponentially distributed with parameter theta equal to 1 by 2. He is asking in exponential distribution. He has given theta. Not only theta, he might give lambda, he might give p, something, some parameter he might give. But remember, the parameter is nothing but theta in exponential distribution. So that is nothing but 1 by 2. What is the parameter that repair time exceeds 2 hours? He is asking about repair time. Okay, fine. So in order to repair a machine, what is the probability of exceeding 2 hours? That is nothing but, let x be the repairing time. X be the repairing time. Suppose, for example, so what he is asking, this time should be greater than 2. Yes, greater than 2 hours. So how can we say that this greater than 2 is nothing but, first of all, we should have some PDF function, right? What is PDF here? According to distribution, theta value is 1 by 2. So theta into e power minus theta by x, right? So where is the dust, friends? Okay. Theta into e power minus theta into x. Is this the probability distribution function? for exponential distribution case? Yes. Now what he is saying, what is the value of theta? 1 by 2 he is given. So 1 by 2 into e power minus x by 2. Yes or no? This is the PDF, probability distribution function f of x. We defined this. Now what is this formula? Greater than 2 he is asking. That means 2 to infinity. So what is the function he has given? We have framed e power minus x by 1 by 2 into e power minus x by 2 dx. So 1 by 2 comes out integral 2 to infinity e power minus x by 2 dx. Yes or no? So 1 by 2, what is e power integration? E power minus x by 2 by minus 1 by 2 from 2 to infinite. Yes or no? So this 2 will get cancelled here. So minus e power minus x by 2 limits are 2 to infinity. So fine. So upper limit minus lower limit, minus e power minus infinity by 2 minus of minus e power minus 2 by 2. Yes or no? Upper limit minus lower limit. Yes, this value is 0 because e power minus infinity is 0. Minus into minus is plus. E power 2 by 2 is cancelled 1. E power minus 1, that is nothing but 1 by e. 1 by e value. What is the value of 1 by e, friends? That is nothing but, I think it is 0.3679. Yes, this value will be 0.3679. Okay, so this is the answer. Just look at the question, friends. He has not given us the PDF function. In the previous questions he clearly mentioned f of x value, but here basing on this parameter and he has given that exponential distribution, we have to obtain the PDF. That is nothing but theta into e power minus theta x. Okay friends, hope you understand. Next case. Now coming to next distribution. Okay, so now friends, so far we have discussed the 4 distributions. What are those? Binomial, Poisson, rectangular distribution or uniform distribution, and exponential distribution. The final distribution is Gaussian distribution, friends, which is also called as normal distribution. This is very important. See, listen carefully. Normal distribution is another limiting factor. It is a limiting factor of binomial distribution under following conditions. When n is very large, okay, or neither p nor q is very small. When both these two are not small and n is very large, then we have to go for normal distribution. Okay, see, f of x equals to, the probability density function for a Gaussian distribution is f of x equals to 1 by sigma into root 2 pi into exponential of e power minus of x minus mu whole square by 2 sigma square, where sigma is nothing but variance. Yes or no? Sigma is nothing but variance and mu is called mean. Yes or no? This is the formula. Here the x value should be from minus infinite to infinite, and the mean value should be also from minus infinite to infinite, and this one is nothing but variance. Variance is always non-negative, which is greater than 0. So this is the probability density function for a normal distribution or Gaussian distribution. Okay friends? So let us see, friends, standard normal random variable in the sense when mu is equal to 0 and variance is equal to 1, that is mean equal to 0 and variance will become 1, then the formula will be manipulated to 1 by root 2 pi into e power minus x square by 2. So practically when we substitute the values from minus infinity to infinity on the place of x value, mu values and variance values, we will get this type of graph. Okay friends, we will get this with graph. This graph will be symmetrically bell-shaped figure. Symmetrical in the sense when we close these two, symmetrically it will occur, symmetrical to y-axis, and it's a bell-shaped curve, friends. It is a bell-shaped curve, and remember the practical values. These values are fixed for a Gaussian random distribution. See, at 0, from minus infinite to 0, the area will be 0.5. From minus 1 to 0, from minus infinity to minus 1, from minus infinite to minus 1, the area will be 0.43. From minus infinite to 0.2, the area will be 0.4747. From minus infinite to minus 3, area will be 0.4986. From minus infinite to 0, the area will be 0.5. In the same way here also. Okay friends, we can calculate. We can calculate the area. These are the practical values, friends. Scientists have given us, so we have to take granted. So from infinite to 1 value, it is 0.3413 area. Infinite to 2, 0.4742. Infinite to 0, the area of the curve is 0.5. So in this case, remember these values, friends. Okay, 0.3413, 0.4742, 0.4986. In this way, you just remember. Now let us see areas under different normal curves. Okay, Friends, now let us see different areas under normal curves. These are all practical curves, friends. Let us see once just a sort of analysis and application regarding this normal distribution. Okay, fine. Suppose this is the bell-shaped figure, right? Bell-shaped curve. So P of z less than or equal to z0. Z is nothing but normal distribution random variable, Gaussian random variable. Let z is a Gaussian random variable. If z0 is positive, that means if suppose z0 is here, okay, if suppose this is the z-axis and z0 is here, so P of z is less than or equal to z0. Z is less than or equal to means this part, right? Suppose if I could take this one from here, what is this part? This is the less than part of z0, the part which is less than z0, right? So what is the area of this part, friends? This, up to here the area is 0.5 up to here. Suppose this part is a, this part is nothing but a, okay, this is nothing but a. So what is this, friends? From below z0, from probability of z less than or equal to z0, what is the probability, friends? 0.5 plus a, right? If you want to find the area, there is nothing but 0.5 plus a. Next, probability of z less than or equal to z0. Suppose z less than or equal to z0. If z0 is negative, suppose z0 is negative in the sense here it will be there. Suppose now this is the value here. Okay, fine. Now what he is saying, probability of z less than or equal to z0. Less than of z0 means left side part. This is nothing but this area, right? So how can I get this area, friends? See, until here this is 0.5, right? Up to here 0.5. Up to here 0.5. If suppose this area is a, this open area, this area is a, if I remove from 0.5, if I remove this particular a, can I get this part? Yes or no? That's why 0.5 plus minus a. Got my point? Next, probability of z greater than or equal to z0 he is asking. Suppose z0 is here. If z0 is negative, if z0 is negative, suppose greater than he is asking, right? So the part will be like this. So this is 0.5. Suppose this part is nothing but a. Now what we will get, the total area from here z0, 0.5 plus a, right? Okay, fine. Now this z0 is negative. If z0 is negative here, z0 is positive here now. Positive. So that's why z0 is in this axis. Now z is greater than or equal to z0, right? So it is greater than, right? So that part. This is nothing but, this particular complete part is nothing but 0.5. Right? If suppose this is a, in particular 0.5, if I remove this a, can I get from this part, right? So 0.5 minus a. So this is the way to analyze these curves so that to obtain the area, friends. Okay, he will be giving you the a value, then you have to find according to the given condition. Okay, next one. So next one, friends. If suppose probability of z1 less than z2 equals to, suppose z1 is negative, z2 is negative, there is one part here, another part here, the area we need in between these two. So how can we calculate the area between these two, friends? See, that is nothing but, suppose this area will be given as a1, this value will be given as a2, a1 plus a2, right? Simply, so a1 plus a2, in order to calculate like that. These values will be given to you in the question. Fine. Next one, important note, friends, for a standard normal variable. What is a standard normal random variable? Standard Gaussian random variable is nothing but when mean becomes 0 and variance becomes 1, it is called a standard normal random variable. Mathematically, for Gaussian random variable, when it is in standard form, then the format will be x minus expectation of x divided by root over variance. Okay, friends, and this should be minus 3 to 3. After 3, friends, it is very much negligible actually, the value. Hence, most of the range we will take as from minus 3 to 3 according to the graph, right? So now let us do the problems basing on Gaussian random variable. So before going to problems, friends, let us discuss about the properties of normal distribution. The curve is bell-shaped and symmetrical about the line x equals to mu always. We have already discussed, this is the curve, right? And this is symmetrical to this curve. X is equal to mu means y-axis, right? Okay, friends. Now, I can also say that x minus mu equals to 0, right? So this is 0. This is x minus mu equals to 0. That is x equals to mu curve. So, okay, this is symmetrical about that line. And it is bell-shaped. Okay, fine. Mean, median, mode of the distribution always coincide. See, I will be discussing in the next coming classes mean, median and mode. Until then, hold on. Next. Only thing remember is these three will get coincide. Okay. Next one. As x-axis increases numerically, f of x decreases rapidly. Yes. As x is increasing, f of x is decreasing. Fine. Next one, the maximum probability occurs at the point at x equals to nu, and it is given by maximum probability occurs at this point, right? So what is that value? 1 by sigma root over 2 pi. So that's the coefficient maximum, because and at that particular one x minus mu is 0, right? X minus mu is 0 in the sense in the formula if we apply only this e power 0 will be nothing but 1. So 1 by sigma root 2 pi will come. Next, x-axis is an asymptote to the curve. Asymptote in the sense this line is prolonging and at infinity it becomes 0. These lines go to infinity along this line. This line is called asymptotes. That is nothing but x-axis is an asymptote to the curve. Next, total area under the curve is always unity. The total area if we calculate, it will be unity, because until here it is 0.5, until from here to here is 0.5. Both if we add, it becomes 1. Okay. So next property is, so next one friends, area property. Probability of mu minus sigma, mean minus, what is the sigma friends? It's nothing but, what is the sigma? See, root variance is nothing but standard deviation. Yes or no? So variance is nothing but square of standard deviation. That means sigma square. Variance is nothing but sigma square. The sigma is nothing but standard deviation. Less than x less than mu plus sigma equals to 0.6826. Right friends? Now, next, mu if of p of mu minus 2 sigma less than x less than mu plus 2 sigma, this value will be 0.949544. This is 0.6826. Remember, these are practical values. Okay, next, p of mu minus 3 sigma less than x less than mu plus 3 sigma. This value will be equal to, this is nothing but, see friends, listen carefully. I have already given you certain values. See, minus 1 plus 1, minus 2, minus 3, plus 2, plus 3, right? I have been given these values. Yes or no? Until here 0.5, until here 0.413, right? So, he is calculating, adding these two values and giving this one. It's nothing but at the same time, from minus 2 to plus 2, he is giving these two, adding these two values and giving this value. Like that. Okay, individually they are separate. When you are getting added, the area between these two is like this. Now, the standard normal distribution is z equals to, z is a standard normal distribution variable, z equals to x minus mu by sigma. If we let, when expectation is 0, this one already we have discussed. Expectation is 0 and variance equal to 1, z equal to x minus mu by sigma. Okay, the PDF for z equal to f of z will become 1 by root over 2 pi e power minus z square by 2. Okay. This formula is very important friends, that's why I am stressing again. Just note down. Okay, now friends, let us see a question. If x is a normally distributed random variable with mean equals to 30, okay, he has given mean equal to 30, that is expectation of x is 30 and standard deviation equals to 5, sigma equals to 5, fine. So these are the questions that he has asked. Let us do this. So he has given on a random variable, but we have to find the values on z. So z term, that means p of x less than 25 in the sense p of z. In terms of z, how much it is less? We don't know. So we have to apply in this formula. He has asked in 25, right? So x equals to 25. What is the expectation that he has given? 30 is the expectation divided by, what is the standard deviation value? 5. That is 25 minus 30 is minus 5. Minus 5 by 5 equals to minus 1. So z will be associated with minus 1. X is less than 25 in the sense z means normal distribution random variable friends. This is random variable, this is Gaussian random variable. We have to convert the value to Gaussian random variable which is less than, that's why this formula is important. This formula transfers that. So z less than minus 1. See in the graph we have seen this is minus 1, right? If z is less than minus 1, this is the area, right? Yes or no? So if we need to find 0.5 minus this area should be eliminated. This area should be eliminated from 0.5 so that we will get this value. So what is the value at minus 1 friends? Did you remember the value at the minus 1 is 0.3413? Yes or no? 0.3413, right? So 0.5 minus 0.3413. Yes or no? So what is the value now? So 0.5 0.3413. So this is 4. Carefully do the calculation, and this is 7851, 0.1578. So 0.1578 is the value for probability of random variable x is less than 25. Okay, now see the next one. What he is asking? Second one is probability of modulus x minus 30 less than 5. See friends, what is mod x less than a? Is nothing but minus a less than x less than a, right? Yes or no? So what we have to do now, this is nothing but probability of minus 5 less than x minus 30 less than 5. Is this no? So can I take 30 to both sides? How I will get? So minus 5 plus 30 less than x less than 5 plus 30. So what is the value friends? Minus 20, no, it's 25 less than x is less than 35. So this is Z1, this is Z2, right? So how I will get the value friends? So I have to convert this into which one? In Gaussian random variable. This is Z1. This is Z2. If I have like this is nothing but x1 minus mu by sigma. Mu is nothing but expectation, right? The same formula. This is x2 minus expectation by sigma, right? So for this, what I will get? What is x1? 25. 25 minus what is the expectation, friends? That nothing but mean. Mean is nothing but expectation by sigma is 5. Yes or no? Correct, right? So next one. This one x2 is 35 minus 30 divided by 5. What is the value? Minus 5 by 5. Minus 5 by 5 in the sense minus 1. This one 5 by 5, that is nothing but 1. So this particular value will be tending to probability of, in terms of Gaussian random variable, minus 1 less than z less than 1. Yes or no? So minus 1 less than z less than 1 in the sense, what is the value? At minus 1 and then what are the values, friends? So I told that when there is a Gaussian distribution function from here minus 1 to 1, this is a1, this is a2, right? Both will be get added in this case. So this one at minus 1, what is the area? 0.3413, right? Plus 0.3413. Right? Both the areas are 0.3413. If both get added, what is the value? 0.6826. So for probability modulus x minus 30 less than 5 is 0.6826. So what is the answer for this one? 0.1578, and for this one 0.6826. Did you get my point? Now let us see the third one. So now let us see third one. This is nothing but probability of random variable is greater than 40, x greater than 40. Now we have to convert this into z. That means this is x minus mu by sigma, right? So what is x here? 40. 40 minus 30 divided by 5. That is nothing but 10 by 5 equals to 2. So this implies this is equal to, in Gaussian random terms, z is greater than 2. Here greater than is greater than 2. What is p of z greater than 2, friends? That is nothing but, what is p of z greater than 2? At particular 2, what is its value, friends? 0.4772, right? See, this is the one, this is 0, 1, 2, at particular this value 0.4772, right? Yes or no? So if I want greater than 2, I need this area. So entire 0.8, I should eliminate this a. Yes or no? Until here 0.4742 is the value. So how can I write 0.5 minus 0.4772? It's nothing but 0.50000, 0.4772. How can I eliminate? 4. This is 9, this is 9, this is 8. 8220, 0.0228. So the value is 0.0228. So the probability for z greater than 2 or probability x greater than 40 is 0.0228. In this way we will calculate. Okay friends, next one. See what he is asking, the fourth one. P of x less than 30. P of x less than 30. So P of x less than 30 in the sense this is x. So 30 minus 30 divided by 5 in terms of z. So this value is nothing but 0, right? So what does it mean? P of z is less than 0. See, in P of z less than 0 in the sense, in the according to the bell-shaped curve, this is 0. What is less than 0? The entire area. The entire area is nothing but 0.5, right? We have already discussed, nothing but 0.5, direct one. Okay, so these four are very important. Basing on the basing on the values of the bell-shaped curve, we will calculate. First of all, only the thing is convert this x values into z values, friends, by using this formula. Then only you will obtain. Fine. I hope you understand. Next. Okay friends, now let us see some important values or some important notes in Gaussian distribution. Just remember all these things. Don't get confused. Just remember these will be directly useful in your while doing problems. See, probability of -1 less than or equal to z less than or equal to 1 is the value will be 0.6827 friends. From -1 to 1, this is the, right, from -1 to 1 the addition will be this value. From -2 to 2 this value will be 0.9545. From -3 to 3, from -3 to 3, so this value will be 0.9973. Okay friends, in that way you remember. Next, probability of -a less than or equal to z less than or equal to a. This property is very important friends. In I think EC or EEE, in prelims paper of IES, he has framed a beautiful question basing on this. Remember friends, we will do that problem now. See, probability of -a less than or equal to z less than or equal to a. This is 2 times of probability 0 less than or equal to a less than z less than or equal to a. When -a and a is there, he has saying that from 0 to a, write from 0 to a and put 2 in front. So this property is nothing but, see friends, -a to a f of x dx. If the function is even, how can I write from 0 to a 2 into 0 to a f of x dx, right? Why? Since the function is even function. Since this z is nothing but the Gaussian random process, Gaussian random distribution ka curve hai na, whose curve, this curve is nothing but in bell shaped and it is symmetrical about a y axis. That is nothing but it is an even curve. So since the Gaussian distribution is an even function, even distribution, so this property also holds. So 2 into area under the normal curve between z equal to 0 and a, 2 times of the area. Okay, fine. Next, p of -a less than or equal to z less than or equal to b. I can split them as from -a to 0 I can write, and from 0 to b I can write. In the same way, if at all it is minus, I can reverse it, 0 to a, from 0 to b. Right friends? Hope you understand. Next one. Probability of z greater than or equal to a is nothing but 0. Greater than or equal to a in the sense, suppose this is a, greater than or equal to a in the sense from 0.5 minus this part I can eliminate. So p of 0 less than or equal to z less than or equal to a. I eliminated that part. Next, this is nothing but area between z equal to 0 and a. This is the area between z equal to 0 and a, right? So these are also, we have already discussed it through diagrams, but anyway once again let us see. P of z less than or equal to -a I can write as p of z greater than or equal to a. When symbol changes, less than or equal to will turn to greater than or equal to. Next one, p of z1 less than or equal to z less than or equal to z2 equal to p of 0 less than or equal to z less than or equal to z2 minus p of 0 less than z less than or equal to z1. What is inherently first is comes second term. Remember in that way. Next, what is there in the second term will comes in the first term, right? Beginning with 0. Next, ninth one is probability of -z1 less than or equal to z less than or equal to -z2 is probability of 0 less than or equal to z less than or equal to z1 minus probability of 0 less than or equal to z less than or equal to z2. Remember this one. Next, 10th one. Probability of z less than or equal to a gives you 0.5 plus probability of 0 less than or equal to z less than or equal to a. This is also we have discussed this property. According in first starting in the basic curves by doing the area of the curves, I have told this. Next one, probability of z greater than or equal to -a equal to probability of z less than or equal to a. Okay friends, so these are the 11 important notes. Please note down. Please read them thoroughly so that you can solve questions in less number of time. So next question friends, look at this question. This is IES 2017 question. 2017 IES, he has asked this question, but this model is important. This model is very important. See, if x is a normal random variable or else normal variate is nothing but variable only with mean equals to 30 and standard deviation equals to 5. That means he is asking us mean equals to 30 he has given and standard deviation sigma equal to 5. Okay, what is the probability of, he is asking this one. Fine. So probability of 26 less than or equal to x less than or equal to 34. He is asking this question, right? Okay. So we need to convert this x into z terms. How can I convert 26 minus mu by sigma less than or equal to x minus mu by sigma? Can I write like this? In order to convert 34 minus mu by sigma, then it will, this is nothing but z, right? So p of 26 minus, what is the value of mu? 30 divided by 5 less than or equal to z less than or equal to, in order to turn z, apply minus mu by sigma both sides. Next, 34 minus 30 divided by 5. So this value is nothing but minus 4 by 5 less than or equal to z. This is minus 4. The sigma standard deviation value is 5, right? Yes, it is 5. So 36 minus 26 minus 30 is minus 4 by 5. Yes, less than or equal to nothing but 4 by 5. This is nothing but P of minus 0.8 less than or equal to z less than or equal to 0.8. Yes or no? So this is how we are. I have already noted the formula previously. P of how did I write that formula? P of minus a less than or equal to x less than or equal to a. How did I wrote 2 into P of 0 less than or equal to x less than or equal to a. Right or not? In the same way, what is the value of a here? 0.8. So in the sense, P of minus 0.8 less than or equal to x less than or equal to 0.8 equals to 2 times of P of 0 less than or equal to x less than or equal to 0.8. Yes or no? So what is the value now? This is also equal to, from 0 is nothing but, how can we write this? 2 into, he has given P of z equal to 0.8, he has given as 0.2881, right? So how can I write this? This is nothing but P of z equals to, this is not x friends, this is z, yeah. Here z equal to symbol, right? 0.8. The property holds, this property, the other property holds, so 2 into 0.2881, that is nothing but, so 2, 16, 17, 5, 0. So okay, so answer is 0.5762, option B. So Gaussian distribution is somewhat complicated, but only the thing is you need to understand, you have to convert from x domain to z domain. You have to convert the random variable to normal Gaussian random variable. So, and then you apply the properties by remembering those important values. Okay friends, this is all about the probability and the random variables. Hope you like these videos. Thank you so much. Now a small topic is remaining, that is mean, median and mode statistics. Let us also discuss those topics. Okay friends, come on.